Hey, welcome back. Just thought I'd throw out some new content today. So we're looking at 2.6, Formalizing Relations and Functions. So your Common Core State Standard is FIF1, which says, understand that a function from one set, called the domain, to another set, called the range, assigns to each element of the domain exactly one element of the range. Okay, so we're going to talk about what domain and range means. Also relations, vertical line tests, and function notation. Alrighty. A relation is a pairing of numbers in one set, called the domain, with numbers in the other set, called the range. A relation is often represented as an ordered pair, x, y. In this case, the domain is the set of all x values, so that's something important to remember, and the range is the set of all y values. A function is a special type of relation in which each value of the domain is paired with exactly one value in the range. Okay, so if you look at this, it says identify the domain and range of each relation, represent the relation with a mapping diagram, and determine if it's a function. So when you're doing mapping diagrams, this is what it looks like. So I'm going to write D for domain, R for range. I'm going to put a little circle over here. That's not a circle, those are ovals. And then you're going to list all the elements of the domain in the circle. So the domain is all the x's, so here, 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 and here. So I get -2, 0, 4, and 5. And then I'm going to list all the y's, here, 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 and here, in the range value. So 0.5, 2.5, 6.5, and then 2.5. But notice I have two 2.5s, so I'm just going to list that one time. Okay, so now we need to map the domain onto the range. So -2 goes with 0.5, so that goes like this. And then 0 goes with 2.5, so that goes like this. Oops. Anyway, 4 goes with 6.5. Bang, bang. 5 goes with 2.5, so it's back up here. Okay, so notice we have 2 of the domain elements going to the range. Okay, that's okay, but as long as each element of the domain, so each of these, is only going to one range value, then it is a function. Okay, so this one is a function, even though 0 and 5 are both going to 2.5. Now let's look at B. We have domain here, range here. Okay, 6, 4, 6, which I already have, so I'm not going to list it again, and 5. I have 5, 3, 4, and 8. That's all my y values. Okay, now I'm going to map each of these. So 6 goes to 5 like this. Ka-chow. 4 goes here. 6 again goes to 4 now. And 5 and 8 go together. So this one would not be a function because of this 6 right here. Okay, the 6 can only go to one range element. So the domain 6 can only go to one range element. So this one is not a function. So basically, if you have two of the same x values, then it's not going to be a function. 2 of the same y values is okay. That's this one over here. That one's okay. This one is not okay because you can't have 2 of the same x values. Okay. So that's a mapping diagram. So I want you guys to try that on this one. List out each mapping diagram for A and B, and then determine if it's a function. Okay, go ahead and try that. Pause this. And 3, 2, 1, pause. Alrighty, so your diagram should look like this for A. You've got 4.2 going to both 1.5 and 0, and then 5 and 7 going to 2.2 and 4.8. So this one is not going to be a function because your domain of 4.2 is going to 2 ranges. So that's not okay. Not functional. Okay, on this one, every domain is going to only one range. And actually every range also only has one domain. So this one is a function. And this is a specific kind of function which is called a one-to-one function. And that means every domain has only one range and every range has only one domain. So we don't have like one going, or wait, no. We don't have like another one. So say we had 0 here. We don't have that going to 1 as well. Okay, because then it wouldn't be one-to-one. But if every one just has one pair in the range and domain, then it is called a one-to-one function. One-to-one function, like that. Okay. All right. So this B is a function. A is not because of the 4.2 going to both.
y values. Okay, so we also have another way to determine if a relation is a function, and that's called the vertical line test. The vertical line test says if any vertical line passes through more than one point on the graph, then for some domain value there is more than one range value. So the relation is not a function. Okay, so if we graph our points here and draw a vertical line anywhere on the graph, and it crosses more than once, then it can't be a function. So let's try that here. So I'm going to plot each of these points. Okay, so I finished my graph and I plotted these points. Okay, there's 1, 2, 3, 4, 5 points on this graph. So if I draw a vertical line anywhere on this graph, for example, right here, or right here, or right here, and it crosses, and I have 2 points that cross that line, 2 or more, then it is not a function. So if you look at this one right here, at -4, I've got this point right here that crosses, and this point right here that crosses. That would be this one and this one. So because I have more than one point right there that crosses, it is not a function. Okay. On B, so for B I'm going to have you make a table. So you can go ahead and do this. Let's plug in -2, -1, 0, 1, and 2. Okay, I'll fill mine in and you can fill yours in and then we'll graph it. Okay, pause this in 3, 2, 1, pause. Alright, so I've got my table filled in now. At -2, if I plug that in, I get -1 for my y. I'm plugging it into this equation right here. -2 squared is 4, -4 plus 3 is -1, and then so on. Now I just need to plot these points. So my first point's going to be here, -2, -1, so about right here. -1, 2 is going to be right here. 0, 3 is up here. 1, 2, and then 2, -1. Okay, and this is a y equals, so this is actually going to be a curve, so I can sketch the curve like that. Okay, now if I take my vertical line and I place it anywhere, like here for example, it only crosses once at this point right here, or I could place it here, see it only crosses once right there, or I could place it here, still only crosses once, or I could place it here, still only crosses once. So anywhere you put it, it only crosses once, and it has to be a vertical line, so I can't do like a diagonal line like that. It's always got to be vertical, like this. Okay, so this one passes the vertical line test, so that means it is a function. Hooray. Okay, so that's the vertical line test. Alright, so let's try it with these ones. Go ahead and plot A and B on a graph, and then I will do so as well, and then see if it passes using the vertical line test. Okay, pause this in 3, 2, 1, pause. Alright, I've got mine graphed. This is A, this is B. So for A, notice these are just points. This is just a set of points, so I'm just plotting each point. I'm not connecting them with lines like that. So if I take and draw my vertical line, here it only crosses once. Here, well, it doesn't cross any times, but if I hit that point, it would only cross once. Only once there. Only once here. Only once here. So no matter where you draw, it only crosses once. So this one is a function. For B, if I draw it here, it only crosses once. But if I draw it here, right on the axis, it crosses 3 times. So that one is not a function. Definitely not a function. Yes. No. Okay, so B does not pass the vertical line test, so that means it's not a function. Okay, next one. You've seen functions represented as equations involving x and y, like y equals -3x plus 1. Below is the same equation written in function notation. So basically we've just replaced the y with f of x. Okay, we read that f of x. That basically just means the function f of x. So f is the name of the function, x is the name of the variable. Okay, your independent variable is x. So if your variable was like z, we would say f of z equals -3z plus 1. Or you could even say like g of z. This, if your function was named g, say g of z, or something like that. But this x or z right here is not multiplication, so it's not f times z or times x. It's f of x. So you don't have to solve for x and divide by f or anything like that. This is just basically the same as your y value. Okay, so if we look at this one right here, the function w of x, not w times x, w of x, equals 250x represents the number of words, W of x, you can read in x minutes. How many words can you read in 8 minutes? Okay, so if we want to know what 8 minutes, well, we know x is our variable, and that's in minutes. So I'm going to replace all my x's, like this, with 8. So 250 times 8, like this. And again, it's not w times 8. This just means w of 8. So when your x value is 8, your y value is 250 times 8, which is 2,000, I think. So 2,000. So w of 8 equals 2,000. I'm not dividing by 8. This is just your final answer. So 2,000 words in 8 minutes. Okay, this is useful because it shows you your y value, which is this one, and your x value, which is here. So when x is 8, y is 2,000. That's basically what that's showing you. Okay, how can you read in 6 minutes? So basically you just replace 6 there, and it's 250 times 6, which is 1,500, I think. But same problem. Okay, this one, it gives you a domain of this function, f of x equals negative 1.5x plus 4. So it's just giving you the domain, which remember is your x values. So these are your x's. What is the range? So to find the range, we just need to plug in each domain value. So I'm going to plug in 1, then 2, then 3, then 4. So f of negative 1 equals negative 1.5 times negative 1. I'm just replacing the x with negative 1 plus 4. So that's going to be negative times negative is positive 1.5 plus 4, which is 5.5. So that's one range value. Okay, so I guess I did that wrong because, oh shoot, I should just plug in positive 1, that's why. Okay, so actually that's going to come out to be negative. So negative 1.5 times positive 1 is negative 1.5, plus 4 gives us 2.5. So we look for these, which one has 2.5? This one does. This one does not, so we can cross that out. This one does not, that one does not. Wow. Okay, well, I guess this is just obviously A then. So it's got to be A here. So that's the nice thing about multiple choice. You just have to figure out the process of elimination. But if you want to plug in the next one, f of 2, that should be positive 1 now. F of 2 is going to be negative 1.5 times 2 plus 4. So that's going to be negative 3 plus 4, which is positive 1. And there's that positive 1 there. There's the negative, or the 2.5. If I plug in 3, negative 1.5 times 3 plus 4, that gives us negative 4.5 plus 4, which is negative 0.5. And that's that one. And then the next one, f of 4, is going to give us a negative 2, if we went through and did all the math again. So that is your range values. So that's all your y values for these x's right here. Okay. Alright, so I'm going to have you try it with this one. Just state all the range values for each of these 4 domain values, these x's. Okay, so go ahead and try that. Pause this in 3, 2, 1, pause. Alright, so I've gone and done this one. I've plugged in all of these for my x's. So g of 1, 4 times 1 minus 12. That's 4 minus 12 is negative 8. I've got 0 for the next one, then positive 8, then positive 16. Okay, so these are all your ranges here. So when you write your range, you can go ahead and make it a set like this. We use these little curly brackets to represent sets, like domain and range sets. That's why it's used up here as well. Okay, but I just list at negative 8, comma 0, comma 8, comma 16. So that's saying all of those are elements of the range. So those are all your y values, basically. Okay, last one. It says you have 3 quarts of paint to paint the trim of your house. A quart of paint covers 100 square feet. The function A of Q equals 100Q represents the area, A of Q, in square feet that Q quarts of paint cover. So Q is the quarts of paint, A is the area. What domain and range are reasonable for the functions? What is the graph of the function? So first thing about your domain, okay, so you only have 3 quarts. So your domain, oops, this is actually a continuous function because you can use really any number of quarts. You can use 1 quart, 1.5 quarts, 1.25 quarts. So really our domain should be from 0 to 3. So I'm going to put brackets around those, and if you remember, this is interval notation.
So I use 0 to show where it starts, because I can use 0 quarts of paint, or I can use up to 3 quarts of paint. So I can't use any more than 3 because I don't have that much. I only have 3 quarts. Okay, and you can use anything between those. So you can use 1, 2, 2.5, 2.75, whatever, however many quarts of paint you need. So then to find the range, you have to actually go through and figure that out. So A of Q equals 100Q is our function. So I can plug in 0, because that's going to give me the lowest number, 100 times 0, which is just 0. So our range can start at 0, and then the highest number I can plug in is 3, so I'm going to say A of 3 equals 100 times 3, which gives me 300. So it's going to go from 0 to 300 square feet. That would be the range, that would be the domain. Okay, then the graph of the function, well, I would just plot each of these points. This one's linear because it's y equals 100q. There's no squares or anything like that. So you can just plot the points, 0, 0. That's what I got from this one right here. And then 3, 300. And it would be a line that's going up like that. Something like that. Probably a lot steeper than that, but yeah, that's the idea. Okay, last one. What domain and range would be reasonable if you had 7 quarts of paint instead of 3 quarts of paint? Okay, so I'm going to let you guys figure that out. So go ahead and try this, and you can pause it in 3, 2, 1, pause. Okay, was this going the whole time? Oops, I thought I paused it. Maybe not, sorry. Okay, so your domain in this case would be 0 to 7, because that's how many quarts you have. So then your range would be 0 square feet to 700 square feet. Okay, if you look at B, it says, why does it not make sense to have domain values less than 0 or greater than 3 in problem 5? Well, you can't have negative quarts of paint, so we're going to start at 0, so we're starting at 0 there. And you can't have more than 3, because you can't paint more than 3 quarts, because that's all you have. So 3 is going to be the max, or in this case it would be 7. Okay, so that is domain and range. Make sure that it makes sense given the scenario that you were given. Okay, that's all I've got for you today. This was kind of long. I might have forgot to pause it, but sorry. Yeah, make sure you do the Canvas quiz, and I will catch you all on the next one. Adios, amigos, amigas.